Today we're talking about climate and the factors that affect an area's climate. So before we move on, I want to make sure we understand what the term climate means, and we're not getting it confused with a similar term that's weather. Weather are the conditions outside right now. So what I mean by that is if I were to take a look outside at my window, well, I don't actually have a window, so we'll use my imaginary window. There, that's better. So if we take a look outside my imaginary window and we describe the weather that we see right now, we could describe it as sunny. Maybe it's cloudy. It could be rainy. It could be windy. It could be warm. It could be cold. The weather outside could be lots of things, but as you know, the weather is not the same every day. So weather is the conditions outside right now, and weather changes from day to day. It could be hot one day and cold the next. It could be sunny one day and then rainy the next. So weather is always changing. Climate is the measure of an area's weather over many, many years. We're talking decades or centuries. So it's kind of the average weather. So what do I mean by the average weather? Well, we could have places that are warm, or we could have places that are cool most of the year. Now, that doesn't mean that it's warm every single day or cool every single day. It just means in general it's a warm place or a cool place. But we can vary it even more. There are some places that are warm and wet. Take a look over here. That's a tropical rainforest. It's a warm, wet place. It gets lots of rain. You can even see some of the moisture hanging in the air. Some places can be warm and dry. Take a look over here. Here's a desert. A desert typically is a warm, dry place, although there are some cold deserts, but most deserts are warm and very dry. But we can also have places that are cold and moist. Take a look here. This is actually a picture from the Pacific Northwest, up near the Seattle region of our country. And it's a very wet place. It's a rainforest, but it's also a cool place. You can see in the background, you see that white stuff up on the mountains? That's snow. It's a cool place, but it's also a wet place. And we also have places that are cool and dry. Over here, you're looking at a tundra. Notice in the background, you see lots of snow, and there's even some snow on the ground right in front. That is a tundra. It's a cool, dry place. It gets very Now that we know what we're talking about when we use the word climate, let's talk about the three factors that affect an area's climate. The first one we're going to talk about is elevation. And when I say elevation, I want you to picture this. Imagine you went to the beach, and right where the water meets the sand, you put a ladder. And as you climb that ladder, you're going up in elevation. And we measure elevation in feet above sea level. Here in Naples, Florida, depending on where you live, we could be somewhere between 6 to 12 to 18 feet above sea level, which is not very high. There are some ladders that get as high as that. But other places, like in the Rockies, it can be thousands of feet above sea level. That's much, much higher than we are here in Naples. And what happens is it gets cooler the higher you go. Now, if you were to climb up on a 6-foot ladder, you probably wouldn't notice much difference. But as you started to go up higher and higher, imagine you had a ladder that stretched up maybe 10 kilometers. That's really, really high. As you started to go up, it would get cooler and cooler. The place on Earth with the highest elevation is Mount Everest. It's about 9 kilometers or about 5.5 miles above sea level. Imagine you had a ladder, you could climb 5.5 miles up. That'd be pretty high. Well, once you get up that high, the temperature begins to fall quite drastically. At 9 kilometers above sea level, the temperature drops to negative 45 degrees Celsius. That's negative 49 degrees Fahrenheit. It's 49 degrees below zero in Fahrenheit. That's a very cold place. So as you increase elevation, the temperature begins to decrease. That means the higher you go on a mountain or imaginary ladder, the colder the temperature gets. That's because the air up in the upper atmosphere is much, much colder. This is also why water vapor condenses when it rises into the sky to form clouds. Take a look at this picture. What do you notice? Well, you can see in the front of the picture there's cactuses. It's a desert. But in the background, what do you see? Snow. Well, this is proof that elevation is a determining factor in an area's climate. You can see the sand and the desert right in front, so it's a warmer place, or at least above freezing. But in the background, the mountain begins to rise in elevation, which means its temperature begins to fall. So in the background, the only difference between the desert and the mountain is elevation. And the higher you go on the mountain, the colder it gets. And that's why you can have snow. The next factor that we're going to talk about is something called latitude. Now, latitude is a little tricky because sometimes we don't know what that word means. We'll take a look at this picture over here. Do you notice there are several lines on here? Do you notice how the line in the middle is dotted? That's the equator. So when we talk about latitude, we're actually talking about how close to the equator are you. The equator is 0 degrees, meaning it's not north, it's not south, it's 0, right in the middle. And as you begin to move north, the numbers increase 1 degrees north, 2 degrees, 10 degrees, all the way up to about 90 degrees north, which is the North Pole. And the opposite happens as you go south from the equator. As you move south, the numbers increase as well, but we call them 1 degree south, 2 degrees, 10 degrees south, all the way down to about 90 degrees south. So the three areas that you need to know about on a map with latitude are over here. We have the tropical climate, which is near the equator. So any place near the equator is a tropical climate, which usually means it's very warm because it gets sunlight all the time. It gets a lot of sunlight all year round. And this is where we find a lot of our coral reefs and a lot of our deserts and a lot of our rainforests, because there's lots and lots of sunlight, which means lots and lots of heat. As you keep going north or south, you reach our second climate area, which is the temperate climate. Temperate means it's not too hot and it's not too cold. This is a place where you find the 4 seasons. In winter, it's cold. In summer, it's warm. It's hot. And spring and fall, we have those in-between temperatures. So places that are in the temperate zone, we find lots of our temperate forests, which is places that lose their leaves in the winter and have the nice green spring. And as you continue to move further north or further south, you come to our third and final climate area, which is the polar climate. And a polar climate is a cold climate, and it also has very little precipitation. Lots of snow, but very little liquid rain. And that's what we're talking about, the North Pole or the South Pole. So when we're talking about the climate of an area and we want to know how latitude affects it, the closer the area is to the equator, the warmer it's going to be typically. And the further from the equator, meaning getting closer to the North or the South Pole, the cooler it's going to be. So the tricky part to remember is the equator is 0. So as you increase in latitude, which means to go up or down, that's what the tricky part is, to go up or down, north or south. When you increase your latitude, going closer to the North Pole or closer to the South Pole, the colder it gets. So a place that's around 10 degrees north is going to be warm, but a place around 50 degrees north is going to be much, much cooler. So remember, when you increase latitude, increase means you get closer to the North Pole or South Pole, it's going to get colder. And when you decrease your latitude, which means you get closer to 0, that's going to increase your temperature. I like to remember that the equator is 0, and that's the warmest place, and the bigger the number, the colder the temperature. The third and final factor that we're going to talk about is proximity to water. Now, proximity to water is a fancy way of saying how close are you to an ocean or maybe a really, really big lake. So proximity to water is how close an area is to the ocean. Now, what does that mean for an area's climate? Well, when an area is close to an ocean, we say it has a mild climate. And mild just means it's not too hot and it's not too cold. So an area that is near an ocean during the winter won't get as cold as an area that is not near an ocean. And the opposite is true. An area that is near an ocean during the summer won't get as warm as an area that is not near. Take a look at this picture over here. What you're looking at is a map, and on the map you can see on one side we have London, and on the other side we have Winnipeg. London's a city in England, and Winnipeg is a city in Canada. What's important to know about this map is London and Winnipeg, they're almost an equal distance to the North Pole. Now, here's what's interesting. If you were to visit London in the winter, it'd be a cold place, but you wouldn't always see snow. And if you were to visit Winnipeg in the winter, it'd be covered in snow all the time. Well, why is that? If they're both just as close to the North Pole as one another, why wouldn't they both be just as cold? Well, what do you notice about London? London is on an island, the United Kingdom, and it's very close to an ocean. And Winnipeg is out in the middle of Canada, nowhere near an ocean. So London has a warmer winter than Winnipeg, not because it's closer or further from the North Pole or the equator, but because it's near an ocean. So how exactly does being near an ocean make your winters and your summers more mild? Well, let's take a look. I want you to imagine that I'm London, as you can see here. And London is on an island, and an island is surrounded by water. So I have my thermometer here, and it's going to show us the temperature. I want you to imagine the thermometer is in the ocean. And in the summertime, it gets nice and warm in London like it does in most places. The average temperature in London is somewhere around 66 degrees Fahrenheit. But the ocean, if you can see, is only about 50 degrees, maybe 45 degrees. So if I'm London, and it's getting warm in the summertime, and I'm next to a very large body of water that's cold, what do you think is going to happen? Well, it's going to cool me off. There's going to be a cool daily breeze that's going to take the heat away. It's going to keep my temperatures nice and low. Okay, so now I've changed. Now I want you to imagine that I'm Winnipeg, which is out in the middle of Canada. And if you remember, I told you in the summertime in London, it gets to about 66 degrees on average, which is a pretty cool summer. Now in Winnipeg, it's nowhere near a large body of water. It's way out in the middle of Canada. So my thermometer this time is not going to be in water, but it's going to be in land. So in Winnipeg in the summer, the land gets warm up to about the mid-80s on average in Winnipeg. So if I'm the city of Winnipeg and it's getting up into the 80s and 90s, and I'm surrounded by land that is in the 80s or 90s, what's going to happen? Well, it's not going to cool me off. There's no cooling effect. So since I'm in the 80s and 90s and I'm next to land that's 80s and 90s, nothing's going to cool off. Okay, now I want you to imagine that I'm, again, London. And this time, instead of summer, it's going to be winter. So it's getting really, really cold in London, and the temperature of the water, it maybe dropped a little bit, but it's only gone down a couple of degrees, maybe down into the 40s or into the 30s. Now, as it gets really, really cold in London, I happen to be next to this ocean that is actually warmer than I am. So what's going to happen? Well, it's going to warm me up. So London stays warm in the winter because it's next to a warm body of water. Now I want you for the last time to imagine that I'm in Winnipeg. And in the winters in Winnipeg, the temperatures dip very, very low into the negatives. So -10, -20, it gets nice and cold. So as the temperatures begin to fall in the winter, and remember, we're going to go all the way down into the -20s. Remember, Winnipeg's surrounded by land. There's no water nearby. As the temperatures dip in Winnipeg, the land around me is also in the negative numbers, which means there's nothing there to warm me up, which is the exact opposite of London. If you remember, London's surrounded by water, and as the temperatures in London begins to drop, it happens to be next to water, which helps warm London up. But Winnipeg, it can't get warmed up. So what does that teach us? This teaches us that an area that is near a large body of water will stay cooler in the winter and warmer in the summer because the ocean acts as a heat transfer. It either takes the heat away in summer or it gives heat in the winter.